Welcome to our YouTube class. This is Kadika National School. I'm Mr. Scovian Otieno Dira, chemistry teacher. I want to take you through a process, an industrial process known as Ostwald process. It is a process which is being used to manufacture nitric 5 acid in large scale. Realize that nitric 5 acid is a more volatile acid. It can be manufactured in the laboratory when we use concentrated sulfuric 6 acid and potassium nitrate. But now, if you want it in large scale, we need to know that for us to prepare it in large scale, that is through industrial process, then it is important that we know that we must have some materials and we must also have some condition so that to prepare this gas. So far, I'll take you through the process now. I'll take you through the process. Stay with us and learn with us. Now, in industrial manufacture of nitric 5 acid by a process known as Ostwald process. I have said that the name of the process is called Ostwald process. It is a process which is being used to manufacture, it's an industrial process which is being used to manufacture nitric 5 acid in raw materials. You must have what is called raw materials. One of the raw materials is ammonia gas. It's ammonia gas. And ammonia gas, we can produce it from a given source. And the source of this gas, which is being used as a starting raw material, we produce it from Haber process. Remember last time we discussed with you that Haber process is also another industrial process which is used to manufacture ammonia gas in large scale. So for us to manufacture ammonia in large scale, for us to manufacture nitric 5 acid in large scale, we must use a raw material. The main raw material which is being used here is called ammonia gas. Otherwise, we can as well obtain ammonia from other different sources by decomposition of organic matter, but that one helps us to produce a small quantity of ammonia gas, which cannot sustain this industrial process. So we use ammonia gas as one of the starting raw material. Number two, another raw material, we use water. And sources of water. Where do you get water, students? We get waters from rivers, lakes, and ocean. So those are some sources of water. We get it from rivers, lakes, and oceans. Another raw material that is important that we discuss with you is air. Air, I know is a mixture of gases, but the specific components of air, element of air that we're going to use here is oxygen. And we are going to obtain it from one source, that is fractional distillation of liquid air. Now, the two gases, it's important for us to know that the two gases, the two compounds, that is the two gases, ammonia gas and oxygen gas, are the starting raw materials. Water is also going to be used in the process. Now, what is happening here is that these two gases, ammonia gas and oxygen gas, are first purified in the first chamber by the process of electrostatic precipitation. Why do we purify this air? To remove dust particles. And these dust particles, carbon 4 oxide, and any other traces of impurities. And the reason why we remove those impurities is because the impurities are most likely to poison the catalyst if they are allowed if they are allowed in the reaction. So they may poison the catalyst. That is why they are being removed in a purifier. After the two gases have been purified, we'll compress them to about a 9 atmosphere. To compress them will help us to raise their pressure, making them to expand. And once they have compressed, we now pass them to the heat exchanger, where we are going to preheat the two gases to attain a high temperature of about 230 degrees Celsius. So after preheating the gases, we pass them to another chamber known as catalytic chamber. In the catalytic chamber, this is where ammonia gas is going to react with oxygen gas in the presence of a catalyst known as platinum rhodium catalyst. The reason why platinum rhodium catalyst is used is because it is less expensive and not easily poisoned. So it is going to be used in the catalytic chamber. So it is a catalytic chamber where ammonia gas is going to react with oxygen to form nitrogen 2 oxide plus water. To form nitrogen 2 oxide plus water. And to balance the equation is simple. I always tell my students that any equation related to the formation of nitrogen 2 oxide in the catalytic chamber, in the presence of a platinum rhodium catalyst. The rhodium catalyst has been platinized by platinum rhodium catalyst. And this role is just to speed up the rate at which the gas is being produced. So there is an ammonia gas is going to be oxidized with oxygen to form nitrogen 2 oxide and water in the presence of platinum rhodium catalyst. So the equation is just being balanced. If you put 45, 46, the equation is balanced. 45, 46, the equation is now balanced. Ammonia is a gas, oxygen is a gas, nitrogen 2 oxide is a gas, and then water is also a liquid. So once nitrogen 2 oxide has been formed in the catalytic chamber, the temperature in the catalytic chamber is very high. It is about the conditions in the catalytic chamber here. The condition in the catalytic chamber and another thing, there is a catalyst. Catalyst here is called platinum rhodium catalyst. Platinum rhodium catalyst. And then there is also a pressure of 5 atmosphere. The pressure of 5 atmosphere in the catalytic chamber. So the reaction in the catalytic chamber is very exothermic. So the nitrogen 2 oxide formed is again cooled back to the heat exchanger. It's passed back to the heat exchanger for cooling. And once it has been cooled in the heat exchanger, in the reaction chamber, now we expect it will now be passed again in the reaction chamber, where in the reaction chamber, we are going now to see the nitrogen 2 oxide formed, cooled at the catalytic chamber, is passed again to the reaction chamber. In the reaction chamber, this nitrogen 2 oxide undergoes oxidation. It will be oxidized by a purified air, not just air, but air which has been purified to ensure that there is no traces of any impurities. So it is going to be oxidized by a purified air to form a blunt fumes of nitrogen 4 oxide. It forms nitrogen 4 oxide. Form nitrogen 4 oxide. So once it has been purified, it will form nitrogen 4 oxide. So the nitrogen 4 oxide formed, is again passed to another chamber known as absorption chamber. Why do we pass it to absorption chamber? It is in the absorption chamber where we are going to react this nitrogen 4 oxide with the downflow of warm water. With the downflow of warm water. And we cannot just react nitrogen 2 oxide with water directly before oxidizing it to nitrogen 4, because nitrogen 2 oxide is slightly soluble in water, but nitrogen 4 oxide will react with the water. So the one that will react with the water is the one that we are going to react with warm water. So we are going to react this nitrogen 2 oxide, nitrogen 4 oxide with warm water. And the question is here, we are going to react that nitrogen 4 oxide with warm water to form nitric 5 acid, and nitric 3 acid, to form nitric 5 acid and nitric 3 acid. So the nitric 3 acid formed, will be oxidized further to form nitric what? Nitric 5 acid. To form nitric 5 acid. To form nitric 5 acid. And this equation is just balanced if you put 2 here to form nitric 5 acid. So in the process in the absorption chamber, the remaining traces of nitrogen 2 oxide, which might have not been oxidized, are again passed back to the compressor to minimize the cost of production. The unreacted gases are again passed back to the compressor to minimize the cost of production. So the nitric 5 acid, this is how we form nitric 5 acid by Ostwald process. So it is of about 65% pure acid and the remaining 35% water at this time. But to make it about 99% pure, we remove this water by passing it through concentrated sulfuric 6 acid, which will help us to dehydrate it to remove the traces of what? Of water. To remove the traces of water. So I want us to see also how to observe it again via flowchart. I want us to observe it again via flowchart to see how the gas is being produced. To see how the gas is being produced. I want us to observe it again in the flowchart and see how that acid is being manufactured by industrial process. So we have the flowchart here with us. We can share together and see how that flowchart is there. So in our flowchart above, we can see ammonia and air. In the first chamber they are known as purifier. In the first chamber they are known as purifier. They are being purified. They're being purified. And the reason why they're being purified is to remove the impurities. And the impurities are unwanted substances which can poison the catalyst. They include dust particles, smoke, as you can observe. They include dust particles, smoke, and they also include traces of carbon 4 oxide present in the air, all the particles present in air. After that, the purified compounds and mixed elements are being compressed to about 9 atmosphere, and in the compressor here, there are parts in the compressor to allow the two gases to obtain high pressure to about 9 atmosphere. That will make them to expand. Then after that, they are passed to the heat exchanger, where I have said heat exchanger plays the 2 roles. One, in the first step, it is where the gases are being preheated, and we preheat the gases to attain an optimum temperature of about 230 degrees Celsius. Then after heating the two gases in the heat exchanger, we will pass the two gases in another chamber known as the catalytic chamber. In the catalytic chamber, the temperature there is very high, it's about 900 degrees Celsius. And it is in the catalytic chamber where there are three conditions. One, the temperature is of about 900 degrees Celsius. Two, there is a catalyst which is being used to speed up the rate of reaction, that is a platinum rhodium catalyst. Then there is also an pressure of about 5 atmosphere. So in that catalytic chamber, I want you to observe there, in that catalytic chamber, ammonia will react with oxygen. Ammonia will react with oxygen to form nitrogen 2 oxide and water. The reaction in the catalytic chamber is very exothermic. It means it produces a lot of heat. So the nitrogen 2 oxide formed is cooled back to the heat exchanger, is passed back to the heat exchanger for cooling. So heat exchanger also helps in the cooling of the gases. So once it has been cooled, it is passed to another chamber there known as the reaction chamber. In the reaction chamber, this is where this nitrogen 2 oxide, is going to be oxidized with the purified air, known as oxygen, with the purified air so as to form a brown fumes of nitrogen 4 oxide. And nitrogen 4 oxide formed is going to be reacted with water, warm water. And I've said here that nitrogen 2 cannot be reacted directly with water because it is slightly soluble in water. But in preference, we use and we oxidize it to nitrogen 4 because nitrogen 4 will react with water to form nitrogen 2 will react with water to form nitric 3 acid and nitric 5 acid. So the nitric 3 acid formed is further oxidized by oxygen to form nitric 5 acid. And the acid produced from this Ostwald process is 65% pure. To produce pure, is 65% pure acid and 35% water. To remove the traces of water, we pass that acid in concentrated sulfuric 6 acid, which is going to help us to obtain pure acid. So the role of the concentrated sulfuric 6 acid there, it acts as a drying agent. And if concentrated sulfuric 6 is not there, we can as well use a solution of, pass it over solution of phosphorus 5 oxide so that we obtain pure nitric 5 acid, which is about 68%. So that is as far as the equation is concerned. Finally, I want us to agree that we have very many uses of the acid. One, these acids are being used in the manufacture of fertilizer, explosives, dyes, and plastics. The acid is being used in the manufacture of fertilizers, in manufacturing of drugs, in manufacturing of explosive. One of the fertilizers is ammonium sulfate. That is one of the fertilizers which are being used to prepare, which are being used from a component of that nitric 5 acid. So this is as far as the industrial process is concerned. I want to give you questions. You react on them, and after a short while, I want to give you questions. You react on them. Then after you reacted on them, I'm going to discuss it with you so that we know how to answer such questions. So I want you to look at some few questions touching that industrial process. Now that we've seen the industrial process how it's supposed to be, I want us also to look at some few questions that we are going to share with you and discuss them as far as this industrial process is concerned. So I will also see your reactions. I want to also see you answering our questions so that we agree that these are the questions that at a point you can be asked to describe in matters pertaining to questions answer approach containing this theory of an industrial process known as Ostwald process. So let us look at the questions. They are there in our machine. I want us to look at these questions. The first question is saying, describe the Ostwald process used in the large-scale manufacture of nitric 5 acid. So we know that it is all about oxidation. I want to agree with you. I want us to agree together that it is about oxidation. The starting raw materials are are ammonia gas and oxygen gas. They are first being purified. After the gases have been purified to remove impurities, they are compressed to about 9 atmosphere, passed to the heat exchanger for preheating of about 230 degrees Celsius temperature, then passed in the catalytic chamber where the two gases are going to react in the presence of a catalyst. Then from the heat exchanger, we know very well that nitrogen 2 oxide is going to be formed. And the nitrogen 2 oxide formed is cooled, is passed to the heat exchanger back from the catalytic chamber where they have reacted, where it has been formed to form ammonia gas, to form nitrogen 2 oxide. So the reason why it is being passed back to the heat exchanger, I have said here for cooling, because at the catalytic chamber, the reaction is highly exothermic. So we will ensure that we cool the gas to lower the temperature of that gas. And the reason why we pass it back to the heat exchanger, we said that for cooling. That cooling of the gas will lead to the more yield of nitrogen 4 oxide when we now react it with what? With oxygen. Because we need a lot more production of nitrogen 4 oxide, which will help us to produce more production of more yield of nitric 5 acid. So after cooling, it will be passed back to the reaction chamber where nitrogen 2 oxide will react with oxygen to form nitrogen 4 oxide. The nitrogen 4 oxide formed is reacted with the downflow of warm water because it reacts with acid, it reacts with water to form nitric 3 acid and nitric 5 acid. So after those components have been formed, the nitric then reacted nitrogen 2 oxide and air are compressed back to passed back to the compressor where the two gases will be again preheated so that we minimize the cost of production. That is as far as that question is concerned. Question number 2, because you have the question, state the raw materials required in the process. And I would wish that we react on that questions. You can type your answer there so that I can see. State the starting raw materials in the process. State them there so that we can agree with you. State for us the starting raw materials. I want you to state for us the starting raw materials. State the starting raw materials. State the starting raw materials. See you stating this material. Now discussing. It is now your work. Now state would somebody have said ammonia gas? And then you tell me the starting raw material and the source. Where do we produce it from? Somebody said ammonia gas, another one said water, that is good. Another one has said air, that is good. Air, that is another starting raw materials. That is good. Water, and where are the sources? Where do we get those raw materials? Like you mentioned ammonia gas. What is the sources? How do you get that ammonia gas? What are the sources of those raw materials that you mentioned? That is very, very much important. So I can see another student mention ammonia. Another one mentioned, that is good, ammonia. So it is fine. So that is good. I've seen everybody have mentioned at least, but now you need to know their sources. You need to know their sources. Like I said very well, that ammonia we obtain it from Haber process. Then I said oxygen, we obtain it from fractional distillation of liquid air. And then water, we obtain it from rivers, lakes, and ocean. So another question, write the balanced chemical equations for the oxidation of ammonia in the Ostwald process. Actually, that equation is very important. You can write it there. And you can observe in the board it is written here. You can also write it and we discuss with you together. The equation is here on the board. The equation is here on the board. This is an equation that leads to the oxidation of ammonia. Ammonia is oxidized to form nitrogen 2 oxide and water. And I want to assist you students here. You'll have to follow with me. The equation is well balanced. It is just 45, 46. That is something that you cannot forget. When you write 45, 46, you shall have balanced that equation. 45, 46. 45, 46, the equation is just balanced. The 45, 46, the equation is just balanced. So that is the equation for the reaction. That is the equation for the reaction. You can as well write it down there. That is good. Let us also look at another question with you. Let us also look at the question now that the equation for the reaction we've seen. So it takes place in the presence of a catalyst known as platinum rhodium catalyst. Platinum rhodium catalyst. Another question. Let us also check on another question. I want us to look at another question. Another question. That is the next question here, question number 4. Question number 4 is saying, and I want you to answer that question. Although I can see you are not yet seeing it, it's okay. We can now see it, all of us. Name the catalyst used in the Ostwald test. So I want you to name that catalyst and state it. Name the catalyst being used in the Ostwald process. Catalyst. Let us name the catalyst being used in this process. Somebody has mentioned platinum rhodium catalyst. That is good. Platinum rhodium catalyst. Platinum rhodium catalyst. That is good. That is good. Platinum rhodium catalyst. And what is its function? What is its function? Yeah, to speed up the rate of reaction. That is good. Samuel, to speed up the rate of reaction. That is good. To speed up the rate of reaction. Speed up the rate of reaction. That is good. And finally, draw a label of a flowchart showing the stages in the manufacture of nitric 5 acid. You draw a label of a flowchart showing the stages involved in the manufacture of nitric 5 acid. Hearing? You draw and label a flowchart showing the stages involved in the manufacture of nitric 5 acid. I know you cannot draw it and to paste it there, but it is there with us. We have displayed it on the screen, and this is good. You can see it there. And just like I said, is that ammonia, NH3, plus oxygen, that is O2 purified, passed compressor, then heat exchanger, then catalytic chamber, Then in the catalytic chamber, it is where ammonia gas is going to react with oxygen gas in the presence of a catalyst known as platinum rhodium catalyst. It is the most preferred catalyst because it is cheap and not easily poisoned. So it will lead to the formation of nitrogen 2 oxide and water. The equation is for balance when you put 45, 46. Then nitrogen 2 oxide is again passed to the heat exchanger for cooling. Then after it has been cooled, it is reacted with purified air to form nitrogen 4 oxide, which is then reacted with a downward flow of warm water. That is important. So we can go to the next question. We can go to the next question so that we just wind up. Can see we are doing good. We can go to the next question, then we just wind up. We can go to the next question, then we just wind up. So my next question here is give 3 uses of nitric 5 acid. Give 3 uses of nitric 5 acid. Give, that is question number 8. Give 3 uses of nitric 5 acid. 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 What are the uses of these acid candidates? Let us look at the uses of the acid, and we mention them. 1, I want to see you mentioning the uses of the acid, uses of nitric 5 acid. Tell us the uses of the acid here. Uses of nitric 5 acid. I want you to tell me the uses of this acid. I mentioned almost 8 of them. Yeah, manufacture of fertilizer, that is good, manufacture of fertilizer. And the fertilizer we talked of ammonium nitrate. When ammonia is reacted with nitric 5 acid, ammonium nitrate is going to be formed. That is important. That is important. So manufacture of fertilizer. We also talked of very many other more uses that I was expecting you to tell me before we wind up the classes. You just need to show up your manufacture of plastics, manufacture of drugs, that is good. We use it to manufacture drugs, manufacture of dyes, that is good. And also we use it in purification of metals such as silver and gold. We use this also in the purification of metals such as silver and gold. Then my last question to you, you are also asked, you can check from my screen again. Why is nitrogen 2 oxide recycled in the Ostwald process? Why do we recycle that nitrogen 2 oxide? Why do we recycle that nitrogen 2 oxide? The main reason why we recycle the gas is to minimize the cost of production. To minimize the cost of production. When we minimize the cost of production, we need to recycle the unreacted gases. We don't expose them, but we need to do what? To recycle them back to the heat exchanger. Then finally, maybe to end up, explain why nitric 5 oxide, nitrogen 2 oxide is oxidized before it is absorbed in water. Why do we oxidize nitrogen 2 oxide to nitrogen 4 before we absorb it by warm water? We do that because nitrogen 2 oxide is slightly soluble in water. So we need to oxidize it to nitrogen 4 so that nitrogen 4 oxide can react with water to produce for us that nitric 5 acid. And that is as far as our class is concerned. If you have more questions, we'll type on our timeline, then we will answer them concordantly. Thank you, and may God bless you as you study Ostwald process, which is an industrial process to manufacture nitric 5 acid. Be blessed.